Hello friends, welcome to this session. In the today's session, we are going to study again the basic terminology second, because in the previous lecture or previous video we studied some of the basic terms which is used in the solid mechanics. So that it is covered in the basic terminology first, and this is the basic terminology second. So in this particular video lecture also we are going to overlook upon other important terms which are required, or it is important to understand from the solid mechanics point of view. Start mechanical properties of the material. Actually, properties which are related to the behavior of the material under the action of the forces. Uh, in this particular subject, solid mechanics, it is important to finding out the different properties, or we in another way the behavior of the material under the action of the forces. So how the material or how the member behaves whenever there is a system of the forces are act, or forces are act onto the member or any structural member under the different condition. So that properties or that values or that quantities, whenever we able to finding out, uh, that properties are called as mechanical properties of the material. So these mechanical properties are very much important at the timing of safe design of any structural member or any machine component part. And we can say that these properties are important when we can predict the life of any structure. Let us start strength. Actually, we studied the strength, that strength is the ability of structure to resist loads. It is a load carrying capacity or maximum load can resist by any member or any structure. That property under the action of any collapse or rupture or distortion. So that ability of the structure to resist load, it is called as a strength. Second, elasticity. It is one more property of the structural member. Whenever there is a forces are acting, the material regains its original shape and size, or we can say the original dimension after deformation, when loads causing deformation are removed. Means when the system of forces are act, at that time the body offers some deformation. So after removing of that load or that forces, the body regains its original shape and size. That property of that material, it is called as the elasticity. In a very simple way, when the load is applied, body get deformed, and when the load is removed, body again gain its original shape and size. So that property, it is called as the elasticity. And those materials are exhibiting this type of the property, that materials are called as elastic material. So below are some of the examples of the elastic material, that rubber, springs, steel and copper. So these are the example of the elasticity. Next, plasticity. So plasticity property is exactly opposite of the elasticity. Plasticity is the converse of elasticity, that is, a material in plastic state is permanently deformed. When the forces are acting, material are under deformation. When the forces or loads are removed, body will not get its original shape and size again. So that it is a difference between the elasticity and the plasticity. So whenever the load is applied, deformation is a permanent, so it has no tenacity to recover. After that, the ductility. Again, this is a one more important property. Under the action of the tensile force on a material, it possible to draw out material longitudinally to a reduced section. Whenever it is possible, it is there when the loads are applied, tensile forces are applied. At that time, if it is possible to draw very thin wires, or we can say the reduced cross section of the material, at that time that particular property is called as a ductile property of the material. As the temperature increases, ductility of the materials is also increases. Brittleness. Brittleness implies lack of ductility. So this is the brittleness property is exactly opposite to the ductility. So in the ductility, there are repetitive the loads whenever it is acting. So that body is it is ability of the body to resist maximum load and can draw on the small thickness or thin wires also. But in the brittle material, the body or material does not have the capacity to undergo large deformation. So this is a major difference. That is a deformation. Large deformation is can produce into the ductile material, but it there is no that much capacity is there of the brittle material, that is a large deformation before failure. So it has very small deformation is produced into the brittle material. Brittle fracture take place without warning. So fracture or collapsing or breaking of the material, it is taken place without any warning giving. So for example, the brittleness material, these are the examples: cast iron, high carbon steel, concrete, glass. These are the examples of the brittleness property. Suitable for resisting compressive loads, but less suitable for resisting tensile. So this brittle material cannot take the tensile load or impact type of the load. It will take some compressive loads which has some compressive strength into the brittle material, but there is a less tensile strength or impact load. Material having less than 5% elongation. So there is a very less deformation or elongation is occur into the brittle material. Malleability. Malleability is a property of material which permits the material to be extended in all the direction without any rupture. So breaking or fracture will not happen into this material. So we can extend, we can elongate material in all the three direction without any breaking or without any fracture. So that property of the material, it is called as a malleability. Or also this material can be rolled or beaten up into thin sheets without any cracking. So we can manufacture the sheets without any cracking from this type of the material. It is the compressive quality of material also. Strain energy. When an elastic body is loaded, it undergoes deformation. At the time of loading, there is an energy store in it. Means whenever there is a load is acting onto the elastic body, at that time body undergoes some deformation, and at the time of deformation, there is a energy is produced. That is called as a loading energy, and that energy is stored in the body itself. And whenever there is a load is removed or a load is released, then when body load is also removed, whenever there is a releasing of the stored energy when the load is removed from the body. Resilience. The strain energy stored by the body within elastic limit when loaded externally is called as resilience. Whatever the energy stored in the body when the loads are applied within elastic limit, that particular property, it is called as a resilience property. Means it is a storing of the strain energy in the elastic limit. After that, the proof resilience. Proof resilience means the maximum strain energy that body can store within the elastic limit. That property, it is called as a proof resilience. It is a maximum energy which body can be stored within elastic limit. Means it is a capacity of the material to absorb the shocks. Modulus of resilience. The proof resilience per unit volume of piece is called as modulus of resilience. So once you, if you able to determine the proof resilience, so by proof resilience per unit volume of a piece is called as modulus of resilience. After that, hardness property. Hardness is the resistance of material to scratching, cutting, or wear by surface abrasion. So it is actually hardness means how much that body or that material offers scratching or resists the scratching or resisting of the cutting or wearing of the surfaces of the material or surface abrasion. That property is called as hardness. So different types of the test can be conducted onto this material to finding out the hardness. That tests such as Brinell, Rockwell are generally performed to measure the hardness of the material. The last property is the fatigue. It is the deterioration of the material subjected to repeated cycles of stress and strain resulting in progressive cracking, eventually producing fracture. So there is a repetitive type of the, or we can say the cyclic type of the stress and strain are happened onto the material, and there is a progressive nature of the cracking which produce the fracture. So that type of the property, it is called as the fatigue property of the any material. So for example, there is a good example is the earthquake. So whenever there is earthquake shocks are produced into the ground, at that time this is a cyclic, because there is a stresses and strains are also produced into the material, and at that time there is a cracks are developed, and that are cracks are progressive, that cracks widths are increasing continuously, and finally it produces the fracture into the material. So this is a type of the property, it is called as a fatigue type of the property in the material. So for the today's session, that's it. Thank you very much.